seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Good evening to our viewers in Europe and Africa. Good afternoon to our viewers in the Western Hemisphere. Good very early morning to viewers in the Pacific Rim. And welcome to the Angry Astronaut. Really appreciate you folks joining us here today. This is a very, very important broadcast. I've got Dr. Ron Levin, the son of Dr. Gil Levin, who was responsible for putting the first ever life detection and the only, to be honest, life detection piece of equipment on a Mars lander. And we're going to be talking a lot about what just happened, and we need to check to see what's going on with the sound 5x5, according to people. So it looks like we're good on the sound. That's great. I am thrilled to hear that. Before we get going, though, thank you very much for joining us.
Glad to be here.
Now we're going to see where everybody's checking in from real quick. We, of course, have Antonym, who always joins us, or usually joins us anyway, from Roswell, New Mexico. Robert, thank you so much for your support right out of the gate, as always. Airborne Bob, a fantastic supporter of this channel. From Valdosta, thank you very much, where my nephew went to college. Hello, Nottinghamshire. Really appreciate you joining us today. And Northern Ireland as well. Thank you. Hey, Skywatcher, I hope you're glad you're here. And I am Jen. Thank you very much for being here as well. Hello, Stockholm. By the way, I'm interviewing someone from Stockholm tomorrow. Another big interview, but you'll find out about that soon enough. Of course, we have ASN in Yorkshire joining us, in Northumberland. Lots of British viewers as usual. We have Newcastle and Manchester. Antonym, thank you so much for your generous support. Really, really appreciate it. We also have Massachusetts and Clifton, Ireland. Hello, Damien. Really appreciate you being here. We have Somerset and another Yorkshire. Thanks very much for being here. We have Darby'sdale. And where else? We have East Coast, USA, and the numbers are growing as the broadcast continues. So once again, to familiarize everybody with who Dr. Levin is, he is the son of Dr. Gilbert Levin, who put the label release experiment on the Viking lander in the mid-1970s. That experiment produced some results that have been controversial, but in my opinion should not be controversial because they were pretty damn conclusive, but we're going to hear more about that. And once again, hello, Derbyshire and North Carolina and Manchester. Thanks, everybody, for joining us today. So let's go ahead and get started. First, tell us, please, about the label release experiment, and if we could have some graphics with that, producer. Some of them are actually labeled label release experiment results.
Okay. My father had the idea for the labeled release experiment in the 50s when he was working at water treatment plants long before NASA even existed. And everything started with Sputnik. My mom took my father to a Christmas party where he met the first administrator of NASA. NASA was only formed as a result of Sputnik. It was our immediate response. And during the party, my father asked, "Are you doing anything about Mars?" And he says, "Yes, we are." And So at that moment, funding materialized for the labeled release experiment, and that was 1953, and that went on throughout the time between then and the 1976 launch of Viking. Now, Viking was supposed to carry 3 life detection experiments and a gas chromatogram mass spectrometer, which was an instrument that measured organics in the soil. Now, to cut to an important moment, the GCMS did not discover any organics, absolute zero. But today, Perseverance and Curiosity and maybe a couple of others have detected plenty of organics. So I'd like to discount the GCMS right off the beginning. Who knows? There are many reasons. The GCMS may not have heated the soil hot enough to drive off the type of organics, or it just may not have worked. And so
to be clear, just to forgive me for interrupting you, the label release experiment produced positive results on Mars in a variety of different ways, and it was only the negative organics results from the GCMS experiment that resulted in NASA discounting the results of your father's experiment. And of course, what we know today from what you just said is that organics do indeed exist on Mars. They've been detected by multiple rovers at this point. So had the GCMS actually picked up organics back then, would the label release experiment have been accepted in your opinion?
Yeah, I think well, I don't really know. I don't know if the GCMS was something that really bothered them or whether it was just an excuse.
Mm-hmm.
But certainly it was the number one reason that NASA said that they did not discover life or that the results were inconclusive. And if you look up the Viking lander, even today, you'll see the GCMS results are quoted alongside my father's, no matter what. But the team set up pre-mission criteria for the amount of radioactive gas that constituted a positive signal, and my dad's experiment went right through it. Okay, and there are some of the graphics.
Right.
Now, I wanted to show this one that says first LR test. I guess it's, yeah, okay, first LR test, this one.
The one on the top. So we are currently looking at the one on the top right of your screen.
So on Mars, they had a active result and a control result. So the soil was injected with radioactive material, and yeah, this one. And within hours, a large amount of radioactive CO2 gas was detected in the headspace of the experiment. Now, and this is the same thing. I just redid it later with computers when they had color. And on the bottom, you see the blue line, and that's the control. So after the first experiment, and this had been planned long in advance, they took a similar sample of soil and they heated it to 160 degrees centigrade, where 100 degrees is the boiling point of water. So they heat sterilized it for 4 hours and then repeated the experiment on that sample. And that's the line at the bottom. That's the control.
Right.
And
so in other words, they subjected it to an amount of heat that would have killed any bacteria in the sample, and then tested it again. And of course, they got what was expected, no result, because all the bacteria were dead. And if it were some sort of mysterious chemical reaction that was creating the results, heat should not have changed the result.
There's a lot of discussion about that afterwards. And so people who didn't believe the results were going through the chemical catalog looking for a very reactive chemical that was destroyed at 160 degrees centigrade. And there's really only a small set of such chemicals. And in order to duplicate the results, these chemicals have to be like 10 or 20% of the soil. I mean, not a realistic proportion. And my dad worked for maybe 2 years after the experiment, after 76, to put together a chemical mixture that would mimic the results. And he was never successful. And according to the literature, I don't believe anybody else has provided curves like that on Earth that were achieved by chemicals. So the people at NASA, they will admit that there was a reaction and the carbon dioxide gas was evolved, but they still say that was caused by some sort of chemistry. They talked about ultraviolet in the soil producing oxides or superoxides or trioxides, going through the chemical book of explanations, but they were never able to do it. Now, when it was all over, maybe 5 years later, my father came up with a way to improve the experiment so that there just wouldn't be any doubt. And he's been trying to get it sent to Mars ever since. It's as simple as the original. And we went over, I went over with a couple of my friends of my father who are still around to see SpaceX. And we gave about a 3-hour presentation about the labeled release results. And we were teleconferenced into their Starship department, the people going to Mars. And at the end of it, they made the following agreement with us that if we would go out and build a sort of non-miniaturized version, a relatively inexpensive version of the experiment, they would send it to Mars for free.
Right. So again, to be clear here, so you met with SpaceX. My understanding is that you had Gwen Shotwell involved at some point in the conversation.
No, she was not there.
All right.
The highest level person that was there, I guess was only there on Zoom, and he was in charge of the Mars landing effort at SpaceX, and he was in, I think, Starbase in Texas, in wherever it is, Bolsa Chica, and so he didn't come in person. And we had wondered if we were going to meet Gwen, and we really hoped we were, but we didn't.
But your contact deals with her on a regular basis. That's why you're thinking you would.
That's how we got in.
Right.
Now, I work at what's now Raytheon, and I'm an engineering fellow there in basically electrical engineering. And I have a friend there, Ann Lee, who's also an engineering fellow. And she had previously been a civilian employee of the Air Force and was the contract representative for the contracts that the government, the Air Force, signed with SpaceX to launch their military satellites. And so the negotiations are for many millions of dollars, and they last a long time. And Anne was present at many of those for a couple of years as a civilian employee of the Air Force. And she got to know many of the SpaceX people, and she met Gwen Shotwell and spent a lot of time talking to her. And she was often in the room with Elon, and she felt that Elon was sufficiently abrasive that she didn't like him being there. And he yelled at the Air Force general who was in charge of awarding the contract, and she just couldn't get over it. And so all the time, we were all hoping we get to meet Elon, and she was hoping we wouldn't.
Thank you so much, Robert. I appreciate you. She figured you had a better chance without him, huh? The thing of it is, I guess the important thing is at this point is that we have a commitment from SpaceX to take this improved experiment over. Before we talk about the improved version of the experiment, I want to backtrack to a couple of important moments. Number one, if we could have that image back that we were looking at, except I want to see the images on the left-hand side instead of the right. Those that show the what's important to know about the label release experiment that found life on Mars is that it never produced a false positive, and it was tested in a variety of very, very inhospitable areas of the world in order to confirm its accuracy. So that image that we had up, yeah, right, we're shifting over to these images here.
Yeah.
Can you tell us a little bit about your dad's work in that regard, and how thorough he was in confirming the accuracy of this experiment before it actually went to Mars?
Well, yeah, as I said, my father had been sort of brought onto the NASA program as early as 1957. That's 20 years before the actual launch. And they had a formal selection process, and maybe 50 experiments were proposed, including my father's. They ended up narrowing it down to 4 experiments. And then when they finished the actual lander, they realized they were overweight. They kicked off 1 experiment, which left them with 3. The 3 winners were my father's, Norm Horowitz, which was called pyrolytic release, and Vance Oyama, who built an experiment called gas exchange.
Right.
Now, both of those 2 scientists had long reputations. Vance Oyama was an employee of NASA, so he was definitely, I think his experiment was definitely going to be on. And so Norm Horowitz, who was a professor at Caltech, and as you know, Caltech is the organization that runs Jet Propulsion Laboratory in Pasadena.
Mm-hmm.
So he definitely was easily selected. But my father, who was not really from the business, had to work very hard to get on. They told him that he couldn't be on unless he had a PhD. And so at the age of like 45, he went back to Hopkins to get his PhD just so he could be on the Mars program.
Mm-hmm.
Then my father claimed that it worked, and NASA said, well, let's make sure. And they sent him all around the world, and they made him test 1,000 soil samples and 1,000 controls, meaning soil samples that had been sterilized, or sterile samples, including dust from the moon, which tested negative. My father did not find any microorganisms in the sample that returned from the moon. And in the military, they care a lot about something called the ROC curve, which is receiver operator characteristics. And it's a measurement of misdetections and false alarms.
Mm-hmm.
You have 2 types of samples, positive and negative. You have 2 results, positive and negative. And my father had a perfect ROC curve. He tested positive every time that it was a living sample, as confirmed by culturing. And he was negative every time that a sterile sample was provided in thousands of tests.
Right.
In the early days, NASA had him go personally to some of these sites and take his experiment out to run it on the soil in extreme locations on Earth. Now, the one picture I see up is Death Valley,
Mm-hmm.
and it says in the caption,
that was the White Mountain one. If we can shift back down to the Death Valley, which is the top image, please. It's there now.
Okay. Yeah. And so what happens is it says the top 2 millimeters have 0.9% moisture.
Mm-hmm. Right. So in other words, we're talking about a soil sample that is almost completely devoid of moisture, and yet still showed positive results on bacteria, because there were bacteria in samples. It's amazing how resilient some bacteria are and the types of environments that they can survive in. And so that's why the idea of bacteria being alive on Mars is really not an extraordinary thing at all. It would seem, to be a pretty logical thing, actually. And so therefore the results also make sense. Do you suppose that that maybe it was kind of a paradigm shift sort of concept, whereby NASA said, well, the gas spectrometer result was negative, and yet, Dr. Levin's experiment says it's correct. And of course, we who is he to say that we found life on another planet? This guy who didn't even have a PhD until we made him go get one, those sorts of things. Do you suppose, because those sorts of things have happened with paradigm shifts in the past, is people not respecting the credentials of the individual?
And they definitely wanted somebody from NASA to discover it, which Vance Oyama didn't. And I don't really know. I didn't understand, and neither did my father understand gas exchange and whether it was really giving a positive or negative. But there's no earthbound history of gas exchange successfully detecting or not detecting organisms. And they did something where they said, well, this is not necessarily designed to detect life on Earth. So just because it doesn't work on earthbound organisms, there's no reason not to send it.
Do you know if Beagle 2, this question has come up a couple of times now from, I guess, Franco. Did Beagle 2 have something similar to this on board?
No.
Do you know? It did not.
No, but my dad worked a lot with them. I think he was talking to them very seriously, but I don't think that they took this experiment.
Okay, we have another question. Given your father's historic claim of detecting microbial life in 1976, your own groundbreaking work, do you believe life elsewhere in the universe might operate under similar bioelectric principles, even without neurons?
Well, okay. My father's friends, they believe in a theory called transpermia, which is that at least microorganisms that we know of are easily transported on meteors across vast distances in the galaxy, at least, and I think around the world. The champion of this is Fred Hoyle, who is a Nobel Prize winner from England for research for physics, for research on stars. And he felt that they did some infrared experiments where they were looking at great distances in the universe, and they see certain biological compounds, even in other galaxies or anywhere as far away as they're able to look. And so Fred Hoyle said that it was not just local to our area, but that the type of life, and I guess he meant with DNA and RNA and everything we know about, he felt that type of life was thoroughly distributed throughout the universe. And there are good planets like Earth, and there are not so good planets like Mars, but they all get infected from outside. And Fred Hoyle would tell you that the moment that the Earth cooled, meteors and so on from the outside infected it with blue, green algae and yeast, which is basically what's in lichen. And there are fossils on Earth of blue, green algae and yeast that go back to the very cooling of the Earth, like when the Earth was finally below the boiling point of water, maybe, and to within accuracy of our equipment, maybe a few million years later, there was blue-green algae and yeast. Now, in the fossil record, those developed very slowly over the next couple of billion years. There's more and more advanced creatures. And about 2 billion years ago, there's a worm called C. elegans. It's a multi-celled organism. And then everything that you and I know about dogs and cats and gorillas all happened in the last 50 million years or something. The last little, out of the 4 billion year life of the Earth.
Right.
It's like exponential increase that leads up to our fine human beings of today. So I don't know exactly what my dad believed, but his friend, a very good friend, Fred Hoyle, certainly believes that the infection on Earth did a lot better. It got a lot further than what's on Mars. Now, we've been looking for multicelled organisms on Mars with the cameras on the rovers, and supposedly, according to Richard Hoover and others, they actually took a picture of a fossil of a crinoid, which is I don't know, maybe it's like a 1 inch long sort of plant that lives on Earth. It's definitely multi-celled, and I don't really know if it's spacefaring or not, something that would survive in a meteor.
Right.
But, and NASA, and this is a famous war story. NASA took out the rock abrasion tool and ground it up almost immediately after taking the picture, rather than taking close-up pictures and studying it further. So I would like to submit that NASA knows whether there are crinoids or not. But my dad only knows for sure that there are microorganisms.
Right. And the evidence, again, strongly supports that. Tell me about the picture here in front of us right now.
Okay.
You and your dad.
That shows you that I knew my father.
Mm-hmm.
My dad brought me to Pasadena for the entire 3-month mission of the Viking landers. And I got a badge, and I got to go into JPL every day and just sit with him while they all had their discussions, and they programmed the lander for the next thing. And in the middle, one weekend, we went out to Apple Valley, which is nearby it's like east and a little north of Los Angeles.
Mm-hmm.
In the 50s, my father homesteaded a place in Apple Valley under the Homestead Act from like 1840 or something.
Oh, wow. Okay.
You get, and there's, I don't know if there's still some, but you get 40 acres, and you have 5 year. If you improve it in 5 years, you get to keep it for free. And improving meant for this thing an artesian well and a like a one-room building. But my dad didn't have that kind of money, and he let it go back to the government. I said, Dad, where was it? And he says, okay, I'll show you where it was. And this is where his 40 acres would have been.
Right. And
at JPL, TRW gave out swag for Viking like you wouldn't believe.
Right. I've seen a lot of it around here. Just so you know, this place is loaded with artifacts from the Viking Mission. These folks, by the way, have been kind enough to let me stay here for the last couple of days and learned a lot about Viking in that time. It's been quite intriguing.
It was a horrible thing when my father died, and he had all of his Mars research. And it's not just that I have the memorabilia; I've got all of his papers too. And what a mess for me. I couldn't let them just throw it out. So I had it all, every single thing brought to LA.
Tell me about this here, this moment, or what you remember about this moment. This is the original results of the label release experiment when it showed positive results here. We have this for, I mean, this is, I'm afraid to even hold this any longer than I did, because it's so valuable. Tell me about that experience, that moment. What you know about it anyway.
Yeah, no. At JPL, the Viking mission was organized into teams, and we were the Viking biology team. There was a Viking imaging team, a lander imaging team, an orbital imaging team, and a meteorology team, and they were all in different parts of the building. So all the biologists were in one part of the building, and we had a computer, ancient like Tektronix computer display, or a bunch of them, and we could bring up that plot. The data came back in various groups. Like the first bit of data came back from a direct link, and it was maybe the first 30 minutes of that curve. And it was a low rate data transmission because it came directly from the lander. Now, later on, maybe an hour later, The orbiter made a close pass to the lander. The lander transmitted a much larger piece of data, and it came through the orbiter, and the orbiter sent that down to the tracking stations. And that's when my father celebrated. After, it was like around 9 o'clock at night, all the biologists were there. Nobody was going home. And so the thing that you just saw on the dish, that much of it had been transmitted to the Earth. And it's a lot less than what's on these plots, because I think that's only like the first 24 hours or maybe even less. Let's see, it's got the time on there. It's in minutes. So that's like 800 minutes worth of data since the injection. And 800 minutes is divided by 60. It's 12 hours?
Yeah.
Okay. So that was the first 12 hours worth of data. And that was enough for my dad to, at that moment, just absolutely celebrate. And he had them print this off the computer screen.
And all the signatures and such.
He went all around. Yep.
Show real quick once again. You have a signature here from Dr. Straat, who is also part of that experiment. There's so many people, I mean, respected scientists involved in this. It wasn't just your father. He was the one who headed it up.
Right.
Still so many.
Well, my dad passed it around. He says, come on, everybody,
Right.
sign this. And it wasn't clear what the significance for sure was going to turn out to be, but nobody refused to sign it.
Right.
Sure, all right.
And they also popped this champagne cork also. But this blew my mind when I got to see this. Mars life here, 1976. Again, do you have any memories, or did your dad share any experiences when they popped that champagne?
No, I was there. I was there, man.
Oh, you were there for it. Okay, tell me about what happened then.
Well, I was just telling you, my dad, he's more social than the rest of the scientists. So he went around and he was all enthusiastic, and he went out and got the champagne and gave everybody a glass and had them sign the cork and sign the graph. And at one very important moment, maybe an hour before that, Pat Straat leaned over and said to my dad, "Gil, that's life."
Yeah. And so it was. At least it seems very conclusive to me, and many other people believe this. Okay, so let's. Oh, I'm sorry.
I just wanted to finish this.
Sure, of course. Go ahead, please.
When she started working for NIH, a government organization, she stopped remembering.
Yes. Once you know that, and that was kind of it, right? Your dad was the one who really continued to stir things up, continued to insist that he had found life when NASA wouldn't acknowledge that. And I mean, how was he treated? Did they just boot him out completely, or what happened?
No, the other people in the room were from the other two experiments, from the pyrolytic release, the people who signed this.
Okay.
And the gas exchange experiment. And they were looking hard as could be for some reason to figure out whether or not they had discovered life.
Right.
Which for many years, my father had confidently told me those two experiments don't work. Don't waste your time trying to understand them. And at some point, Horowitz, he did think that he thought that he had also discovered life, but some points he wasn't sure. And my father told me that Horowitz had detected life on Earth once when they took some seaweed and compressed it by a factor of 20 or something and crammed it into the experiment. It produced a positive result, which is my dad's way of saying it was totally insensitive.
Right.
My father's experiment was sensitive because it used a radioactive carbon-14 tracer, and that when you were detecting the radioactivity from it, you were counting every atom, and 10 to the minus 26, right? 10 to the minus, 6.02 times 10 to the minus 23rd. That is the weight of a single atom, or roughly speaking.
Right.
So Dad told me many times that his experiment was sensitive to 10 living microorganisms. And he's also proud of it because it did not detect remains or chemicals that were left over, that it detected living metabolism that was occurring right then and there.
Right.
And I haven't taken the moments yet to go through exactly how it worked, and I'm sure I'm not going to leave the air until I put out the gory details. But my dad's experiment is not that hard to understand, and there was no question that the results could be modified by calibration, or you had to be a genius to understand how to interpret that graph. It was simple and matter of fact, and it was exquisitely sensitive because of the radioactivity. Now, later on, my dad tried to sell the same experiment to hospitals for culturing bacteria because it responds in, half an hour or even, approximately that amount of time. And in today's litigious world, hospitals turned it down just because it used some radioactive carbon.
All right.
And you need a special license and so on. But there's no license to use it on Mars.
Right. That's a perfect place for it.
That was the best place for the whole experiment to ever go. And it's been, as I told you, my father ran it thousands of times on Earth, and he did have a special license from the new, I don't think it was called the Nuclear Regulatory Commission. I think it was called the AEC at that time.
In those days.
The Atomic Energy Commission. And so he had a license, and it was kind of expensive, and he stored a certain amount of carbon-14 in a safe, a lead-lined safe.
Tell me then about, if we're going to shift gears here real quick, about Chiral LR then, the next experiment that your father tried so hard to get on something,
which
and
NASA
continues to reject.
I'm still trying. Well, yes. Well,
and if we could please, producer, if you could please put up the slide that reads Chiral LR on top of it. It's the first slide I sent you today. And just go ahead and start.
Yeah.
You can discuss it now.
Yeah. Okay. Well, the problem that really came up was the control. The control was heat sterilization, and it was supposed to eliminate any chance that a chemical caused the reaction. And my dad's idea was a control that you could not dispute. It turns out, and you can look in a biology book, that every cat and dog and bacteria and algae, they all use right-handed sugar, what we call right-handed sugars, and left-handed amino acids.
Let me repeat again real quick. Producer, it is the first slide that I sent you today. Chiral, Chiral LR. There it is.
Yeah, there you go.
Okay, I'm sorry. Please continue.
Okay, and that's, my dad loved the engineering design, whereas when he turned his experiment into NASA, TRW totally redid the hardware, but my dad loved building the hardware. This is the chiral dart, and he called it TWEEL. And I'm not sure, TWEEL is it's in the literature. It's some story. I should know what the TWEEL bird was. There were a lot of obstacles, and my dad drew this diagram because he wanted a dart that would shoot away from the lander and get far enough away that you could claim it was not contaminated by microorganisms that were brought from Earth on the lander. The Viking lander was sterilized for, several days, and the sterilization process added almost $500 million to the cost of Viking, because they had to use electronic circuits that could withstand that amount of heat. Mars landers were never sterilized again.
Right.
And
not thoroughly anyway.
No, not at all.
We've had some problems with,
They, because their electronics wouldn't stand it. I mean, they used cheap electronics on Pathfinder, Curiosity, Perseverance, Spirit, Opportunity, and I know I'm missing a couple, and they're not sterilized. And it's pretty sure I'm not going to talk Elon Musk into sterilizing the Starship either.
Right.
And
can't imagine how he's going to do that, a rocket that big.
All true. So my dad built this dart, and it was going to fly away, and soil samples were going to go into 2 scoops that are near the front, and he was hoping to get roughly identical soil samples. And the idea was he was going to use the same radioactive labeled compounds that were used on Viking, except he was going to separate the chiralities. So in one half of this tweel dart, he would expose the organisms to right-handed sugars and left-handed amino acids. And the handedness of it is a reference to the direction in which polarized lasers will turn, with their polarization will turn. So it's just basically left and right-handed are basically scientific terms, but the left-handed and the right-handed molecules are mirror images of each other. And for some reason, the left-handed sugars are ignored by biology. They can't be used. And it seems as if our common ancestor just happened to pop out with one mirror image, reproduced a billion trillion times, and every organism we've ever studied only uses right-handed glucose and not left-handed. So on one side of the experiment is going to be the right-handed glucose, and on the other side is going to be left-handed glucose. And when the results come in and the right-handed glucose reacts and the left-handed glucose does not react, we're going to look at the press and just say, that's it.
So, and if we get those sorts of results, does that mean that we found a type of life that's fundamentally different from Earth life, or the same?
This is something that my dad kept going on about. He kept saying, well, how do we know on Mars that they use the same chirality as what we use on Earth?
Maybe not.
And he said to me, and I always tried to talk him out of it. He said to me, if we discovered the mirror image of the life on Earth, that would really be fantastic. And I said, yes, it really would be, but it's not going to ever happen,
right? Because
we're in one swimming pool of microorganisms, the Earth and Mars. And although we're exchanging meteors all the time, probably we got infected early on from the same outside source. And I would just, my dad was always a dreamer, and he said, Jesus, what a discovery it would be if it was a left-handed organism. And I said, what a discovery it would be if it was a right-handed organism.
Doesn't matter what it was. That'd be amazing.
So we never agreed about it. And he always wrote down in all the sales brochures, the proposals, that he was looking for both right-handed and left-handed organisms. But I feel that the reason why this is such a good idea is that the right-handed organisms are universal. At least they're certainly universal on Earth.
Mm-hmm.
We have never seen a left-handed organism.
Right.
There have been some science fiction shows where people got made in the transporter, they got reassembled, but within mirror image.
Right. And
then they couldn't eat anything. There's a book called Doors in the Sand that my father discovered, to his astonishment, was written as a fiction.
Right.
But it was written just about that idea. So so the question is, how will the naysayers claim that the chemistry on Mars is completely one-sided, chiral, and has nothing, we say if it's peroxide or hydrochloric acid, it's in nature made in equal amounts in left and right-handed forms. And who's going to argue that there's some chemical on the surface of Mars that's only in a right-handed form or only in a left-handed form? And so my dad felt that if they could have separated the mirror image compounds, they would be done. And on Viking, he put in equal amounts of both mirror image chemical compounds, radioactive compounds, in the experiment. And for whatever 50 years, we've been kicking ourselves that the experiment couldn't have had separated ones. There have been so many missions in the last 50 years. Not one of them has had an experiment called life detection.
No, not at all. And that's just an astonishing thing to me, that after you got those compelling results on label release, why wouldn't you want to follow up with it? And then every time that your father's tried to get this alternative label release experiment sent more definitive label, has NASA even given a reason as to why they keep rejecting it?
No, they have said, they say all different things, and they fight dirty. And
how do you define that? When they fight dirty, what do you mean?
Okay, one example: my father's and I think Fred Hoyle and Richard Hoover assembled a proposal for a life detection experiment for some mission. It might have even been an unsolicited proposal, but if you live in Washington, you know that you have to turn in your proposals by the due date.
Right.
Or, if they show up even at 5:01,
sure,
they will not be accepted.
Right.
So then my father made sure that 4 copies were hand delivered to the NASA headquarters office and walked them in. And to his astonishment, in the mail, they all came back about a week later saying that they hadn't been received on time.
So somehow all four didn't arrive on time, according to NASA.
Yeah, or they
lost
it, or it didn't make it in through the mailroom.
It's just bizarre.
It was not bizarre. It's like an intentional.
Yeah, of course.
Get lost.
Now, what about Gil told me that the when I interviewed him a couple of years ago, before he passed, sadly, that the Russians had actually allowed him to put this experiment on, kind of secretly put that experiment on one of their craft, which sadly crashed. Do you know anything about that?
Well, yeah, it was called Mars 96. It was a Russian lander, and this was the time, I guess, well, I'm not sure, 96, I am sure. And my dad was allowed to put something on called MOX, metal oxide detector, I guess. And what it was a bunch of fiber optic cables, and he put his radioactive substrates on the end of them, except they weren't radioactive. They were just regular nutrients for organisms on Earth. And he put a different one on the end of each fiber optic cable, including the different separated mirror image compounds. And he said something like, I'm not calling it a life detection experiment, but the minute that it gets off the ground, I'm telling everybody I have a life detection experiment.
Right. Now, the reason for that is because wasn't NASA insisting that he couldn't give them any of that because it was some sort of proprietary technology? After they reject his experiment over and over again, then all of a sudden they turn around and says you can't give it to the Russians because it's some sort of it's secret technology. They said that to him, right?
Yes, they did, and they would have told the Russians in strong terms not to send it. I'm not sure how my dad slipped it past them. It was just after the Berlin Wall fell, and so he got it on. And then shortly after launch, the Mars 96 probe disappeared under very, I don't know what happened. Rockets blow up all the time.
Sure.
But it made it into low Earth orbit, but the orbit decayed in a day or two, and supposedly it landed in Chile, and it had a plutonium radiothermal generator on board that they definitely wanted to find. They were very interested in recovering the plutonium, but which there was on Viking as well, by the way.
Right, right.
And
Viking kept running all the way till 1982, right?
Right.
It's amazing how long that thing kept going.
Right, and the only reason why it stopped was because the radioactive. It's like a 12-year half-life or something. It decayed away to where it stopped producing power. I think that same thing is happening on Voyager now.
Right.
Voyager has well exceeded its lifetime design, and it's a sad thing. If they thought of some better power source, like maybe a real nuclear reactor, it would probably make it to the next star and have enough energy to radio to tell us about it.
Of course, that would be many thousands of years in the future. Okay, so to go on here, to kind of reiterate back up to something you mentioned towards the beginning of the discussion. You said that you got into SpaceX, you got in front of some decision makers there, and their commitment that they made to you is if you can build this thing, if you can build it, they will come. In other words, if you can build it, they will deliver it on a Starship, a future Starship mission for no charge. So essentially what you are trying to do right now is raise $5 million to actually build the experiment, and everything else SpaceX will pay for. Is that correct?
I think that is true. There's a moment that was very comical, and they leaned over to us. They're kind of cocky there. I liked them.
Mm-hmm.
And they said, TRW spent many millions of dollars miniaturizing the experiment so that I think when it was all over, it was 1.5 pounds and used 50 milliwatts of electricity or some tremendously aggressive size, weight, and power. And they said, don't worry, just build the cheapest lab version. We have so much payload, we don't even care.
Right. And Starship, generally, they don't. So, yeah. So really, that's essentially it. And my understanding of what I've been advising you to do is to build a nonprofit around this experiment and raise money that way through grants and tax-deductible donations. How are you feeling about that now after we've had a chance to talk about it?
I'm a little further to the right, and I've never touched a not-for-profit company, except that Raytheon is becoming one inadvertently.
Yeah.
But there's as I heard more and more about it, I was kind of worried because there's a big bureaucracy,
mm-hmm.
and what I was hoping instead was that somebody who's friends of Elon or Bill Gates or Jeff Bezos would.
I'd say Peter Beck might want to do it.
Very good.
Because he's already sending a life detection mission to Venus. Why wouldn't he want to do this? That would be real high profile.
Well, yeah. Whoever, I would like to think that somebody could just write the $5 million check. Now, I would have it built, I don't know, at least supervised by Richard Hoover, who is retired and used to work for NASA and who is a big name in the life on Mars business. And he has a, I wouldn't say student, but an assistant named Ivana Pakuta. And I thought that those two of them would be in a good position to do it. Now, I could quit my job and do it if I really had the money. Like I'm paid reasonably well by Raytheon, and they don't work me as hard as SpaceX supposedly does, but they do work me pretty hard.
Right. And you have a lot of time to run a nonprofit, that's for sure.
And so, it all depends. If there's enough money, like if $5 million just materializes, and people generally think that I should be part of the effort and design the laboratory level experiment and test it and get the nuclear license and so forth, I'll probably leave Raytheon and do it.
Now, Marina made a good point. Marina's our supporter and friend from Ukraine, who's been a longtime supporter of this channel. She just mentioned, made a good point, that Rocket Lab has already designed a Mars sample return mission, which of course isn't going to happen because it isn't being funded. But if they are interested in something that ambitious, maybe they'd be interested in just putting, an experiment on Mars that could make that announcement, that determination, like you're saying, just to announce that life exists. And then once we know that life exists for a fact, I mean, we know that already, but once we know it to the degree to where the scientific community will actually acknowledge it, that will inspire future missions to learn more about the biology there before we send astronauts into harm's way.
Which is possibly part of the problem. Whereas Elon is determined to send humans to Mars, and he really probably doesn't care whether they get sick or not.
Right.
He maybe cares just a little
bit,
but he can certainly line up astronauts who are willing to take a chance.
Sure.
And now, so there's a certain amount of fear that if living microorganisms are absolutely proven, that could delay Elon's mission. Although I wouldn't let it delay my mission. I would just go anyway.
Sure, go and take the risk.
And I don't know what the government would think about it. And I don't know what's it called, Rocket Lab. Mm-hmm. Rocket Lab would be, if they worked with me, they'd be sort of cooperating with SpaceX, because the only thing I've got is a free ride to Mars, which is, I think on Viking, if you divide the payload by the cost of the mission, my dad was given like $300 million just from NASA, just for the ride. Right. I mean, and so I'm only asking for $5 million. Right. I got a free ride.
Yeah, most definitely. And actually, I'd say Peter Beck, chances are he might even offer you the free ride too on Neutron, that because it'd be such a high-profile mission, his new Neutron rocket, he might want to do that as well. Let's go ahead and see if there are any other questions, by the way, folks, since we're closing in on an hour of broadcasting at this point. And I know some folks have asked questions before. If folks want to go ahead and repeat the questions that they had asked previously for Dr. Levin here, and it takes a moment for them to start popping up in front of us. So bear with us for just a second here.
I didn't see the pictures with the mud yet.
Oh, right. Can we put up, and by the way, can we go ahead and post, producer, an image of tire tracks on Mars? I think it's Curiosity's tire tracks.
It is right. Curiosity.
Dr. Levin would like to mention something about that image once it comes popping up.
They're always claiming, the NASA's always claiming that it's too dry, and there's no liquid water. And technically, the pressure on Mars is just a little bit above the triple point. It depends on where you are. And if you have some salts or solutes, that makes it even more possible for there to be liquid water. And nobody's ever taken a picture of a puddle, but this thing coming up.
Yeah, it'll come up in just a moment. The producer will have it here.
And then I have another picture of snow on the surface of Mars, which is not liquid, but it's under sufficient atmospheric pressure that it did disappear over time. And
real quick here, a question came up: would you like a Beagle 3 mission, a European mission delivering the technology that your father developed?
Yes, I am willing. I'm willing to work with anybody.
There's the snow. Why don't you talk about that particular image? This is the Viking image, right?
This is Viking 2, Viking lander number 2, which landed in Utopia, and in the winter time, they took this picture, which they held on to for about 6 months. The pictures were supposedly being released to the press as they came off, but they kept this one. And what they discovered was that white powder stayed there for about 50 days. And then as the weather...
That long. Wow.
As it got warmer. And then I had a question as well, couldn't that be dry ice? And dry ice is like minus 120 degrees Fahrenheit. And if it wasn't like it was just at the night or just in the morning, it was over
There for
many
50
days.
days,
Yeah.
right? And so it should have melted off at some point
If it
during
were
that
if it were
time.
dry
Right,
ice.
if it were dry ice, so it had to have been snow.
Yeah.
Right.
And so, okay, so this is about, yeah, we think that there's living organisms right underneath of that snow. They wouldn't say snow in the caption; it just says white substance.
Right.
And so, my question is: do you think that's possible for some amount of liquid to nourish some organisms that are just a millimeter below the surface?
Now that's another. Here's another thing that we know that Antonym just brought. Oh, there's our tire tracks. Can you go ahead and talk about that?
Okay.
Okay, we're live again.
Okay,
go ahead and talk.
Yeah,
about
I was just going to say that
tire tracks.
when we look at the pictures, it began to look like the tracks had a very steep angle of repose, or if they had been sand, they wouldn't have remained as long and as steep as they were. So my dad and I just kept poking at NASA that this picture shows if it's at least not liquid water, it's mud. And I don't know how you can look at this picture and think that it's not at least some amount of moisture underneath of those tires.
It looks like it.
It looks like the tires sank a certain amount into the surface and they left deep tracks. So, if you saw that on Earth, what would you say?
Yeah, well, our friend Farouk in New York, who's always here talking to us, he seems to think it's mud as well, and that makes a great deal of sense for me. Let's see here. Do you believe that NASA cannot allow life to be detected because humans might forever be barred to go to Mars? I think you talked about that.
That is one possibility, and in fact, one of my good friends. Well, yes, there's like quarantine. There's a really question of quarantine, and this could prevent any Mars, depending on how the government feels about it, it could prevent any Mars mission from ever getting there. What if we had astronauts there who were sick and we weren't allowed to bring them back to cure them? Or what if we did bring them back and blew out the whole planet Earth?
Right. Yeah, with a horrible disease. Okay, do you think, or do you expect that microbes are going to be present in virtually all locations on the planet, given that both Viking 1 and Viking 2 had positive results?
I would say at least almost all. On the absolute polar caps, I don't know. Like in the dry valleys of Antarctica, my dad did find the requisite 10 organisms where it's both cold and dry. The polar caps are really cold, and as you know, they get solid carbon dioxide on the winter polar cap. So I don't know about the polar caps, but everywhere else, I guarantee you,
right,
there's no place you could have an operating room.
Yeah,
without getting.
You'd have to sterilize it no matter where you are because you'd have so many.
There's not so many, but enough. It's not sterile, is all I'm saying.
Do we have any other questions, folks? Before we wrap up here, and it takes a moment for these to pop up. There's a little bit of a delay. I believe that I apologize. I'm losing my vision here. Can you read that?
Okay. Does Ron believe the filter event that ended life on Mars may one day present the same challenges to Earth?
So did the cataclysm or whatever led to the extinction of most life on Mars? Would you say that we're going to have that happen to us too?
No, I don't believe it, and I'm not sure. We see all these dry rivers and everything, and I've read that it has to do with Mars not having enough of a magnetic field, and that allows water vapor to be ionized in the upper atmosphere, and it kind of gets, Mars is now quite dry. So is the Earth going to? And there's this movie out that I was in a video recently called Blue Planet Red by Corey Dobbs, and I think he's advancing that thesis that Mars is a warning to us to watch out for our climate or our ecology or something, or we'll end up the same as them. And I don't know. I don't believe it. That's it. I don't believe that the Earth is going to turn into a desert.
Right. And maybe someday, but not for quite a long time anyway.
Well, supposedly there's a $1 billion year limit, because the astronomers say that the sun is going to convert to a supergiant in about 1 billion years. And on its way there, it's going to increase its luminosity over the next 500 million years to a level that we will not survive.
Yeah. And that's something that Elon talks about in terms of eventually why the need for colonization will be there. And by the way, folks, I have a video coming up here very soon about that very topic, about Elon's reasons, the compelling reasons as to why we need to colonize Mars, and the actually many other reasons that colonizing Mars is a pretty good idea that have issues that are not necessarily 1 billion years in the future. Would you like to say anything else to the viewers about your father's work, or about your hopes for your future experiment before we close?
Well, I have to ask if anybody could help me and my father, and if anybody out there happens to be Bill Gates
or no high-powered investors, and let's say somebody, there's certainly people who have the money to invest, but aside, of course, from the monumental possibility of confirming the existence of life, what other benefits can there be from life being discovered?
I think that eventually, when I believe the life will be at least a little bit different from what we have on Earth, because it's like Australia, it's well separated from the rest.
Right.
And I feel like the study of it would have medical benefits for vaccines, and understand maybe the basic science of our DNA. And so I think that, like a big scientific discovery, it would have economic benefits.
Well, and then in terms of, this is kind of an off-topic question, but we'll go ahead and make this be the last one. In terms of where the watery moons, like the moons of Jupiter, that sort of thing, do you think the potential for more advanced multicellular life beneath the surface of, say, Europa or Enceladus, do you think does that seem something that's likely to?
It's at least possible.
Right.
I would not be surprised. My father was all mad that they're going to send life detection to Europa and just go around Mars. And and I wouldn't be at all surprised if there's at least microscopic life on these places, Titan, Europa, and I don't know what all the other ones are that they're talking about. Right. And so I would guess, if it's really an ocean underneath of Europa, I would guess there's a good chance that there could be a development beyond the single cell. And the crinoid that, the legendary crinoid on Mars is much more than a single cell.
Yeah, much more.
I don't know what's spacefaring, but I went to conferences with people who put bacteria or single-celled organisms on bullets and shot them at walls with approximately the same G-forces that a meteor would.
Right.
And
they survived.
Oh, yeah.
Wow. It's amazing what these little guys are capable of tolerating.
They automatically freeze dry in space, and they can last many millions of years. And when they hit a habitable planet, they can double every half an hour, and that means they take over the whole planet in a year or something. So, which is my dad's experiment is part of, but the bigger picture I think is that there's well distributed sort of bacteria, what do you call it, fauna or flora, some bacterial life development well throughout the universe, not just here. We always thought, before Galileo, that we were at the center of the universe, but then it turns out under Galileo, the sun is at the center of the universe. But now, as we get to be more knowledgeable, the idea that that life started right here, and what is the Miller-Urey experiment, where some lightning bolt puts some chemicals together to form amino acids. And that was how life originally formed on Earth. And I think life originally came in from somewhere else.
Elsewhere, panspermia.
Yeah, the scientific record, the fossil record shows life evolving from 3,000 genes up to 30,000, which is what we are now, over 4 billion years. But there's no record of an animal or a fossil with 2,500 genes. There's like a missing part of the curve that we don't have here.
And maybe it's someplace else. Maybe it's beneath the surface of Europa, or maybe it's in the lava tubes of Mars. Who knows?
It certainly could be, but it's more likely to be at a place that was blown up by a supernova. The supernovas go throughout the galaxy, boom, 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 spreading rocks, and planets that are around those stars get blown to bits. And so I sort of see like sneeze after sneeze of microorganisms populating the universe.
Well, it's an exciting universe to live in, if that is indeed the case. Having interviewed your father, it was such an incredible experience, and I deeply respect his work, and it is my sincere hope, and I'm going to do everything I possibly can, that his work is acknowledged in the future. I want to thank you very much for your time,
Yes,
Dr.
sir.
Levin. Folks, thank you very much for tuning in. Please don't forget to like and subscribe. Also, check the description for various ways to support this content. Thanks again to Dr. Levin, not only for allowing me to interview him and to talk to all of you folks, but also allowing me to stay here for a few days. It's been an experience I will never forget. So until next time, folks, I urge all of you to stay angry about space.